So up next, we have Sean Murphy, and Sean's going to be talking about detection of floating debris using the floating debris index with remote sensing. So take it away, Sean.
Thank you, Rob. I appreciate it. And with me today is Joshua Panganiban. Josh, if you want to introduce yourself as well.
Yeah, I've also been working with Sean on this a lot, but more on seeing how he can apply to my home country, the Philippines, because that's where the idea kind of originated from. Given that there's a lot of like floating debris and waste that comes out of the rivers, we really wanted to dive in and see how we can use remote sensing and satellite imagery to try to quantify whether or not what is happening in the ground is the same as happening up in satellite. So, Sean, take it away.
Thank you. Well, for some background, my name is Sean Murphy. I'm also a rising senior here at William & Mary. I'm studying biology and data science. Josh, you want to background?
Oh, yeah. And I'm Josh Panganiban. I graduated from William & Mary last year. Now I'm at Northwestern University in their engineering school studying energy and sustainability.
Very brief overview. We'll talk about the introduction to current monitoring and evaluation methods for floating debris, specifically plastic debris. A novel, kind of the focus of this presentation is this novel index called the Floating Debris Index. Current application for this project, and then a brief methodology, and then some future directions that we've been talking about taking this project.
Yeah, to begin with the remote sensing analysis, what we really wanted to do was identify port location in the Philippines where there is a lot of trash coming out of the port. If most of you aren't familiar with the Philippines, it's in the stage where there's a lot of development and there's not a lot of regulation with waste. So a lot of people would just throw plastic bags and like all types of plastics like cement into the river, and it would flow right near many of these ports where the plastic would congregate. What we were initially able to do was look at some port locations in some of the busiest cities and try to go in with some high resolution side imagery and identify whether we could find the barbs of plastic that are floating around. And so the benefit of this is we're able to do this remotely. You don't have to go into the water, which can be really dangerous or dirty at times to identify this plastic. And ideally, we'd be able to replicate this remote sensing analysis all throughout the world where there are plastics just floating around in beaches and in high tourist locations.
So in 2020, this novel index, the Floating Debris Index, was formulated by Bierman et al. It's a really interesting index that's based off of the Floating Algae Index by John McHugh in 2009. This primarily uses shortwave infrared, red edge, and near infrared bands, swapping out the red used in floating algae with red edge to isolate and amplify signatures of floating plastics. There are some interesting quirks about using this just with the nature of these plastic patches. It's often they congregate alongside algae and other particles with different spectral signatures. So we're also using NDVI to isolate plastic waste. We are at the bottom here, apologies. We have a true color image and then a image of the index itself in action. And the interesting thing about this is the scale. So this is an index capable of subpixel detection, which is very useful when we're thinking about, especially these port cities in which patch size may not be large enough to occupy a full pixel. We'll be using Sentinel-8, or rather Sentinel-2 at a resolution of around 20 meters. And so this will be very useful when we talk about classification and the application of this index. So currently, monitoring and evaluation can be very costly when done in person, costly rather time consuming, and relatively slow. By using this index, one of the goals is to evaluate the efficacy of legislation aiming to reduce plastic waste. This can be done using time series analyses, but also to point human groups into a more specified region in order to lower the time needed to evaluate plastic waste. This is the index itself, primarily using near-infrared. We have ported this into Python using raster.io, and essentially, yes, this is for classification, due to a relatively low number of available training tiles, we selected a Bayesian classification model, and mostly aiming to both have a rough estimate for the area of patches, as well as to aim human groups into the rough regions where we anticipate there to be plastic waste patches. And then future applications. This is here as well.
Yeah, so what we were thinking to do would be able to identify where plastics end up, both in the water and in the land. With Esri being able to release like their new land cover at a really high resolution, we're hoping that you'd be able to see like where these plastics end up on beaches and be able to do that evaluation remotely. And so it'd be interesting to see like how much plastic accumulates at the port, and then how much plastic could accumulate in nearby beaches around the area, all by doing that remotely. And then once we're able to identify where those patches land through satellite, then you could send in people on the ground to do the ground truthing.
All right, we went a bit quickly, but if there are any questions, and again, thanks to Rob Rose and the IAC, as well as my advisor, Dr. Dan Rimpel.
Thanks, Sean and Josh. That's really fascinating. The first question is, from a conservation perspective, what resolution do you really need to monitor plastics at, right? Do you care about it? In the picture that you showed, there was a few scattered pieces of plastics versus those big floating islands of plastics that we worry about. So what's your target here? Is it those small pieces or those big islands?
Right. The initial research question was much more centered around localities and municipalities that were trying actively to reduce mainly personal use plastic waste, in which case we would not expect a very large, rather from a source point, we may expect a fairly large patch, but at a 20-meter resolution, we find that there is like recorded application of 10 by 2 detection, and I believe 8 by 2 detection, but that is of a constant patch of like a mesh of plastic bottles. For those kinds of municipal applications, probably somewhere in that ballpark would be useful. Josh, do you have anything to add?
Oh, that's great. So in some ways, this is a way to evaluate whether efforts to reduce the amount of plastics entering the ocean are being effective. Excellent. Okay, we have another question. This is such an interesting and unique application of remote sensing. Thank you for sharing your work on this. Have there been studies that evaluate the different spectral signatures of other types of trash and litter if one wanted to use remote sensing to identify other types of trash, i.e. glass, paper, metal, etc.?
Right, this is very interesting. So there's a lot of literature around the possibility of FDI. One of the issues that we ran into was kind of mixed patches, especially when it comes to vegetation and things with relatively similar spectral signatures. The application is forming an index to locate something that would have a slightly different spectral signature would definitely be possible. I think, Josh, we were talking about presence of heavy metals as well, changing the spectral signature.
Mm-hmm. Yeah, without I guess jumping too much in the science, since we haven't looked up that much information. If like let's say a river has a lot of like pollution coming in, whether or not that would identify our ability to filter between glass, paper, or if it's just plastic. But it does make sense that if there were like a lot of heavy metals, it would have a different spectral signature.
And an index like that, depending on the resolution, but using the same general format would also likely be able to perform some pixel classification. But no, I'm not entirely sure on the kind of available literature on other types.
Excellent. Another question is, do you think you could incorporate ocean current patterns in time series analysis with your method to model debris point of origin? It's almost a track back of where the debris are coming from.
Yeah, so we talked about this actually last week, Josh and I, about, so if we can identify problem areas, so let's get to that. I guess this image is all right. So here it almost does appear as if these patches are following something of a current, right? The application is definitely possible to say like, okay, so we have a point of origin on August 7th here. At the next pass in 2 weeks, we can see there's a migration from point A to point B with if there's a particularly large patch or anything like that. That is definitely possible. It is not currently what we're focusing on, trying to solve the, like, is legislation effective test question. But something like that is definitely a huge application that could be implemented.
Yeah, and we'd like to explore this not just with plastics, but if we're talking about like seaweed or sargassum that's happening big in the Caribbean, it'd be interesting to see just like how or where they would eventually end up.
Right. Great. And one more question, and I really like this one. It'd also be interesting to see how you could combine the BFAST model and the FDI index. So identifying where there are large influxes of trash in certain places or large reductions in waste. Do you think this could be a significant connection between the two methods?
Yes, me and do you want me to take that?
Please.
Yeah, me and Sean were talking about this actually like earlier today, or it could have been yesterday, but what would be interesting for us to be able to do is if we can identify like the proper bands of where plastic would be outputted, then ideally we could see or get an alert where there would be a large influx of plastic coming in. And when BFAST gives you that alert, then that you can tell the ground teams of the local government that, hey, the satellite detected that it's like a high amount of plastic within this location. Maybe you guys should check it out. So being able to do that, and Laura, feel free to jump in as well. She mentioned that we just have to figure out like the proper resolution that we're working at and whether or not it's compatible with the model itself.
Right. In the core, I think we're also relying on an assumption that there would be a large discrepancy in the rate of like waste dumping. If it turns out that there is like a demonstrable influx or reduction at some point, often it at least initially appears that the kind of differences in that rate are relatively slow changing. Data, if there were certain heavy dumping like times of year, maybe in winter or other factors that would contribute to that, it would be possible. But I think it definitely could be possible if we figured out that correct threshold, as Josh was saying.
Great. And we have time for one last question, and then we'll wrap things up. Wetlands accumulate flotsam and plastic usually in the same places as the seagrasses and other natural materials that are essential for nesting for some bird species. Could your method be used in locales like wetlands? And how aggregated would the plastic need to be in those areas to be detected?
That's a great question. short answer, hopefully. I think the dynamics of a wetland definitely would lend themselves to general aggregation, right? And using NDVI to, if we were looking at plastics, using NDVI to filter out algal growth and things like that. A patch of even floating microplastics that had aggregated at, 5 by 2, hopefully 6 by 2 meters, would be detectable. I think at that point, we're looking at a modification to the index in which we account for other signatures that may correct what we're looking for. Off the top of my head, I think that is definitely an application that is possible with the correct tweak.
Excellent. Well, thank you all very much for that presentation and for all the presentations during this session. And thanks everyone who came to this session. I hope you found it as useful as I did. I'm going to share my screen just